And I want to point out that I'm presenting from Xmonad. Nobody thought that would work. Okay. Hi. So my name, this is kind of echoey, right? Okay, well, we'll go with it. My name is Tanya. I'm a site reliability engineer at Google, working on infrastructure. But I'm going to open with a story from my first job. I have a terrible habit of pacing while talking, so let me know if I wander off or you can't hear me or whatever. So this is a picture of very high resolution of my first desk. I worked at a small software house, so like 40 developers, 4 or 5 salespeople, and 1 sysadmin, and that was me. Look, I'm so happy because people wanted to pay me to do Unix all day long. It was amazing. This is our company's LDAP server. Really dumb place for it, but that's where it was. This is a big red switch on a power strip that everything in my desk area is plugged into. Okay, if you're not getting a sense of foreboding here, then I commend you on the good life choices you must have made until now. But remember the power strip. It's going to be interesting later on, unfortunately. This is a box of screwdrivers and other useful tools. It's hanging right above that power switch. And here's some papers and folders and ring binders of the sort that you put a new piece of paper on every day, like something to do with ISO 9000, I don't know. If you're not, in honor of this being a talk about 1998, I'm going to use a popular technology of the time to show you what happened next, even though you kind of already know. Because obviously this happened, like obviously it did. The whole thing one day slowly collapsed, a cascading failure, if you will. And it took out the LDAP server, it took out my desktop, and it was a very exciting day. So it's inevitable that this was going to happen, but it's still instructive to look at why. What's the post-mortem? Like an accident? Yeah, but there's more to it, right? Operator error? So I maintain that there's no such thing as human error, or at least every outage is caused by human error. There's no value in saying that this particular outage was caused by human error. It's not the root cause. If it was an act of God, really, we insulted the gods and had it coming. This is what it was. It was a trap. This is a trap created by my past self and the person I took over from and sent into the future. We can do this kind of time travel thing. It's kind of cool. It was unlikely that this particular failure would happen on any particular day. But when it inevitably did, the consequences were really bad. This is why it was a trap. It was a trap because it forced the user to act perfectly. So I'm going to talk about 7 traps that I see all the time in production. This is the first one, assuming a perfect user. So I imagine most people have read the story by now about a bug Margaret Hamilton found in the Apollo command module. She found some pre-launch program, and if you ran it, it would reproducibly crash the simulation. So they thought maybe don't run this on a spaceship. So she asked for some time to fix the bug, and her bosses said, no, just tell the astronauts not to run it, because they're perfect. So document that this is a program you shouldn't run, and it'll be fine. So obviously the astronauts ran the program. Does anyone think that didn't happen? And it blew away all the navigation data. So then cue this frantic scramble on the ground to get more navigation data so that the astronauts could come home. So human error, yeah, but again, it wasn't the astronauts' fault because they're humans. They're not perfect because humans aren't. A lot of the time, humans aren't even competent. Like when they're paged at 3 a.m. You're not your best self at 3 a.m. But we can spend a little bit of time now making our systems resilient to imperfect users. For example, can we set things up so that a sleepy person or a distracted person or someone stressed and flailing or someone on a spaceship poking at things to see what they do, can we let that person blunder around without bumping into a box of screwdrivers hanging over a power strip like the sword of Damocles? I think of this as giving a small, inexpensive gift to future you. It's like you're sending them a cookie. So a common gift from the past is documentation. It's like that can really be a cookie for the future people, but it can also be such a trap. Like, obviously there's documentation that's wrong, and that can be fun. And there's documentation like the Margaret Hamilton story that is just a band-aid over a bug or a bad design, and, just fix the thing. But the best is documentation that just hates you. Like, documentation that is like, everything it says it's true, but it's set up for you to fail. Here's a real-life example. So your colleague just left, and you want to, remove their access, delete their home directory, whatever. And there's a tool to do that. It's not in your path, so you pull up the user deletion docs, and you see this command line. And most people copy and paste it. And most people don't hit enter before reading it to see what it does. But some people do, or they accidentally copy a new line. It happens all the time. They're not especially careful because they believe, falsely, that the documentation does not hate them. If you take one thing away from the talk, it's this. Don't write documentation examples that delete your CEO. Just that. It's not a nice thing to do to your colleagues. What do these have in common? It's the element of surprise. I love this picture. It's violating the principle of least astonishment because humans run on autopilot a lot of the time. We don't compute everything every time. We match a pattern we already recognize, and we just kind of go with it, and we don't stop and think, am I sure that I know what's happening here? That's a problem when something looks like it matches, but it doesn't. Like the special snowflake. You know the one thing that's not like the other things? Okay, in the pathological case, none of the things in your production environment are like the other things, and that's a really bad gig, and consider your life choices. But more typically, you've got a way of doing things, and then one day something doesn't really fit, and it would take some time to make it fit. So, you decide, I'm just going to remember that this one is a little bit different. You're going to remember it forever. You end up with this long list of things that you can't just index in your brain as abstractions. And if you're not perfect, which unfortunately none of us are, you're going to get it wrong sometime. My favorite real-life example of things that aren't like other things. UNIX. What does RM minus V do? It removes verbosely. What does LN minus V do? It links verbosely. What does tar minus V do? It tarchives verbosely. What does pkill minus V do? Pkill minus V does not verbose. It inverts the matching. It means do exactly the opposite of what I just told you to do. So an exception takes up a bit of mental space, right? Like, this is UNIX. We love it. It's our family. We learn its ways. Not to mention it keeps us employed. Like 10K of your salary is based on remembering this exception. But when we make our own stuff, we can do it differently. So here's the cookie. Don't force yourself or anyone else to maintain a mental list of the stuff that's different. It's not a good use of anyone's time. So no one-offs, no temporary solutions, no overrides. Minimize how often people have to read your dangerous, hateful documentation to find out how things work. There was this great talk at LISA 2010 by John Adams from Twitter, where he said people kept overriding their auto-config push by running chatter plus I on files to make them immutable. And he said they got a team motto, you can't chatter plus I with broken fingers. And then things got better. It's like 7 years later, and I still think of that story. It's like apparently formative for me. So number 3, the great big threatening buttons. Look at that thing. Does anyone not want to push that thing and see what it does? You know what it doesn't do? It doesn't say, this is what I'm going to do. Is that what you expected? And sometimes we might like it to do that. Like in the pkill example above, maybe it would be okay if it had an interstitial where it said, hey, I'm about to kill all of these processes. Is that cool? Is that what you wanted? I think you should stop and ask questions in scripts, even if they're just for yourself. Even if it's just something that you're writing as a temporary little script to solve some problem for yourself. Because the thing about temporary solutions is that they become the solution. And it happens very easily. And people will find big red threatening buttons. Engineers are drawn to them. You can't leave that sort of thing lying around. It's dangerous. So it can happen really easily. Say you're looking for a tool to clean up old records from your customer database, and you dig around and you can't find it, but you know your colleague did something similar recently. I think Bridget and Charity talked yesterday about people looking at each other's bash histories to see what commands they might like to run. But you look in your colleague's home directory, and this is a binary, and it's called delete the records. And you want to delete the records. But your colleague's not around. What do? Maybe you run strings against it to see. Maybe you run a file. I'm not sure. Maybe you do and maybe you don't. I mean, nobody here would, of course. But some people will run that binary with -h or -- help. Because we're used to sane tools. We're used to things that say, here are my flags. Would you like to add -v for verbose and or doing the opposite of what you just said? But this one doesn't. It ignores all of the flags, and it cheerfully wipes away the entire database, and then it goes back and deletes the database files, and it formats the disk a few times. It's not a friendly thing. And your colleague set a trap, and later they're going to say, this isn't fair. This was supposed to run, to blow away our integration test database. It was just for me. You were not meant to run it in production. You're not meant to run it at all. It was in my home directory. But still, both of you are spending the weekend recovering the customer database from tape. So it was a trap, because it was a beautiful big red button just sitting there. There are good ways to pause and make sure that you and the tool share some sort of reality. I love how GitHub does it. You have to show some situational awareness before continuing. A friend told me that at his company, they always add, if there's checkboxes, they always add one extra checkbox for, I have not read this and I'm just checking all the checkboxes. Number 4, super user mode. So sometimes you do need to do a bunch of things a bunch of times, and you don't want to type yes to every single one. A popular approach is to add like a flag, so to say that to trust that users know what they want to do. And it's okay when it's pseudo. It's kind of granular. It's like, do this one thing and I know what I'm doing. But it's less okay when it's some sort of minus force command. That means just trust that I am sane. Just do everything. Just do everything that I say to do without questioning it. Because you might want to be stopped from doing some stuff. And then people start depending on it and they document it. Have you seen documents that are like, if you get this error, ignore it and run minus force? I worked with a tool that had minus force and minus force all. And I think force all implied force, but I'm not actually sure it did. It's not a good tool. True story. True sad story. A person I know was doing maintenance on a system that often paged during maintenance, and he's a good dude, and he wanted to help out the on-caller, so he silenced the alerts. Cool. So someone had made this new nifty web interface to do it. It was a single box, and into the box, you type this regular expression, and it will silence the alerts that you have rights to silence, so just the stuff for your team that will that match the regular expression. So he wanted to silence all the alerts, so he typed in $. He forgot he had super user privileges on the alert silencing device, so it matched all of the alerts in the company, all of the alerts on the system. Did the system say, by the way, you're about to silence all of the alerts. Type, this seems like a remarkable life choice, to continue. It really didn't, it didn't. But it was a quiet evening on call. So and we still call him .star 7 years later. And right, it's good when our tools help us out. When I type a command that's not installed on my Ubuntu box, I love that it gives me the command line to install the package that I need. That's amazing. I would not love it if it just installed something for me and ran a command that it thought I might want. That would be being too helpful, and that's thing number 5. Here's another story that's almost entirely true. So imagine there's a script that does something important. It starts and stops a program that lets people see cute cat pictures on the internet. And so there are a lot of these. It's globally distributed because people quite rightly want low latency cats, and there's lots of them because people want high availability cats. This is an important thing. So 2 facts about the script. There are 2 versions. Version 1 is cute cats, version 2 is really cute cats. And sometimes you need to increase or decrease the quotient of cat cuteness on the internet because Hacker News is getting too excited or something. And so you need to say which version you want to do. But that seems annoying, so the script author said, if you get this version wrong, like you say v3, it'll just default to v2, no big deal. It's very helpful. Number 2, if you leave out the location, it'll do all of them. So that means it's easy. If you want to suddenly bring up all your capacity in the world, you just do, start v2, and it'll bring up v2 everywhere you have. So sit with this for a second. And this is another, if you're not going, oof, then you've probably made good life choices. Because this is what happens. Say you want to move some capacity in South America. You bring it up in Argentina. You say, the version is v1, the location is Argentina, lots more cats for Argentina, you're welcome Argentina. And then you bring down the old capacity. So the version is Chile. Oh, okay, cool, let's use v2. And the location is everything. Down goes every cat picture in the world. So like I said, this is almost a true story. It's true that the script didn't ask if I was sure. And it's unfortunately true that the script author had set it up so this would run in parallel. So every server went down inside a few seconds. The part of this is not true, is that it wasn't cat picture service. It was Google's load balancers. Good times. There are a lot of examples of this kind of trope. You might have heard about the time Google sent all of its web servers for disk arrays. And it was the same sort of thing. It was, if the code got an empty list of disks to be erased, it would do all of them. But of course there were safety checks so that it couldn't ever get that. but someone accidentally, walked around the safety checks or used the code in an unexpected way. If you're doing something dangerous, it's good to have the validation right up against the thing that does the damage, but it's even better if you don't have a thing that does the damage. Because this is a fundamental truth of site reliability. People will find a way to break stuff. People are ingenious. And we can help ourselves out by making it really easy to see when they do. But sometimes it feels like we do the opposite, like we intentionally provide places for bugs to hide. And this is thing number 6. Like the snowflake thing again, like errors that aren't problems, you've got to memorize them. You're debugging something and you look at the log and you're scrolling past 50 lines of, oh yeah, I know that's not a real problem, I know that's not a real problem. You just got to memorize all the things that aren't real. Or getting paged for things that are real, but that aren't urgent. We talk about error budgets, but we need to also consider adrenaline budgets. We need to have something left in the tank when something really real does come in. Or alerts without context. So say you just got paged because your storage is at 90%. Is that cool? Do you need to react? Like, it really depends, right? What was it an hour ago? Has it been at 89% for a year? If so, you can go back to sleep. Has it been 40%? Was it 40% half an hour ago? In that case, you got to type really fast. The alert is useless without that information. So put that context in the alert. And actually, once you've got that context, maybe you can decide whether to fire the alert or not. Runbooks are a great way to add context. Do people mostly use runbooks, playbooks these days? Sort of, maybe, yeah. So it's like a little bit of information on each alert, and you link to it from the alert. So it gives your on-caller a head start. It's like, I just got paged, I don't remember how to read or what any of this stuff is, but it just gets you started. Another thing that we use a lot is fix-it weeks. I don't know if people use fix-it weeks. The idea is over the weeks, you get all of this small stuff that needs to be fixed, like alerts that page when they shouldn't, things without runbooks, error messages that aren't really errors, and it takes time to swap in the context at the time to fix it. So you schedule 1 week a quarter where you do nothing but fix these things. And you put it into your project planning. 1 week a quarter, we're fixing this stuff. And then you reward the people who fix a lot of stuff. Final trap I'm going to talk about. My colleague John Reese, he's giving a lightning talk about this later, about haunted graveyards. It's an expression we got from him. It's the parts of production that everyone's afraid to touch. Like that library that was written by some psychopath in 2004. And it's a maze of twisty callbacks and scary pointer arithmetic. And this variable doesn't seem to do anything, but also you think it's structural. And maybe, we'd like to fix it, but everyone uses this library and it's too scary. And maybe if we just don't look at it, it'll keep working. In olden times, a lot of people had a server they were afraid to restart. And now it's like whole parts of production that we're afraid to restart. The longer you leave it, the worse it gets. Like, can we fail over to the other data center? Ooh, I wouldn't do that. If you've got processes that you're afraid of, you really need to do it on your own terms, under controlled circumstances. Because if it's going to break, which it's going to break, everything breaks, you want it to break while you're staring at it. Everything breaks sometimes. That's entropy, man. The even worse kind of fear is blame. So if you really want to hide problems, make people get in trouble for causing them. Because there's no way in hell they'll tell you when they broke something. My best on-call shift ever. It's New Year's morning, and I was on call for Google's monitoring system, the thing that pages everybody else when there's a problem. And suddenly, all of the tasks, every one of them restarted, like quietly down and up. And then a couple of seconds passed, and then they did it again, down and up. And there's nothing in the logs. And I'm looking, trying to see anything that could have caused this. And after a bit of debugging, I had to send an announcement mail. And it felt like half the engineers on the planet, because a lot of people like being paged. And I had to say, this thing that I'm responsible for is broken. I don't know why it's broken. I don't know why it just restarted. And I don't know if it's going to do it again. So you might not get paged. Just, I don't know, look at your graphs with your eyes or something. But before I got back to debugging, I had an IM from someone saying, oh, I was trying a thing, I'll stop. This is the best of all possible outcomes. We learned from this outage, like we learned from every outage, and our alert delivery system is more robust now. But I would also argue that our whole organization is more robust as a result of outages like this. Because If it wasn't safe for that guy to IM me and say, oh yeah, I was the person who broke this, then he wouldn't have done it. He would have just quietly stopped. And it would have taken me a long time before I was confident walking away. And maybe I still wouldn't know. Maybe I would still be waiting for the thing to break again. But he can do his best work if he can admit that he broke something. And similarly, if I can mail all of these people and be like, I don't know what's going on here. I haven't been able to solve this problem without feeling embarrassed. Like, that's a place where I can do good work. And also it greatly reduces the time of the outage. We talk about blameless post-mortems in SRE, but I would go even further. I mean, I love blameless post-mortems, but here's what you can do when someone breaks something. You say thank you. You say thank you for finding this edge case, or thank you for highlighting this overcomplicated piece of our system, or thank you for pointing out that our documentation is no good for this, or thank you for pointing out that we really should have logged the query of death before we ran it rather than afterwards. This is a whole box of cookies for yourself and your organization and your ability to debug outages. And then you make it so that nobody can break it the same way again. We add all these little hurdles. Like, I don't think we mean to, but we make our systems complicated. Complicated is easy, simple is harder. It takes longer to do it right. But these little traps in production, they take our time away from the actually interesting problems we could be spending our precious finite brain glucose on. So, last thought. You can do more than removing traps. You can go above and beyond for future you and for the people you work with. Like, send messages to the future. You can anticipate what mistakes they'll make. You can anticipate what will confuse them. You can add every search term to the top of a doc, including misspellings of the thing that they're looking for, and the internal code name and the external code name, so that when somebody's searching for it, they'll be able to find your document. You can write comments that will tell people not to make mistakes that you know they're going to make, or better, make it programmatically impossible for them to make the mistakes, but you do what you can. And you can write little notes to your future self, like, hi future self, this works like this because whatever, we got the numbers in this way. If you want to regenerate the numbers, this is how you do it. And by the way, it's going to seem like a really good idea to do this thing, but don't, and here's why. You will thank your past self for sending a message like that, for preventing you from breaking something. Because it means that when you do inherit a mysterious package or a library or an entire production environment from the person you were last year, you don't have to stop and stare at it for a long time and think, what is that past person sending me? I don't really trust them. You can be pretty sure that it's just going to be awesome. And that's all I got.